Here we are in lesson 8. Same input controller from the previous lesson where we made the level creator and editor. We have our player, same components, and we have a new game controller. We have our level layout data controller and the level game controller script attached. We have new game information. We've added a CNAME and layout index, which defines which of these layouts will currently load for this level. Let's start the game controller. So we have the game controller, and this game controller is going to persist game data, not using DontDestroyOnLoad as we did in our persistent game controller, where we're going to serialize the data and save it to disk. C# has a neat little class diagram viewer here. So let's explore what we've done and what's to come. Okay, from here on out, the coding have quite a lot of lines of code, scripts, and we'll be closing it off. So here we have a class diagram. If I can just zoom in here to our game controller. Okay, so we've defined our game controller previously. And it has these fields, methods, this behavior. We have a persistent game controller which derived the game controller's behavior, and we persisted the game data with DontDestroyOnLoad. Now we'll be using, yes, it's an upgrade, a huge upgrade, the level game controller, which in turn will also persist the game data, but it will be persisting the game data through the level information. The level information implements Serializable, which will allow us to make custom serialization data for our save state and load state. Okay, I think we can bring that up to keep our bearings. Okay, so now we're here in the level game controller. We inherit from our game controller and we implement this interface, which gives access to the game state, and the game state can change in derived classes, but this is how we can inject new game states as we implement new behavior in our game controller, again without having to change the base class. So everything we do in here, we don't want to change it when we upgrade or when we introduce a new game state. We want to use it, and we just add in the game state type and we add it to the game state method to add new action method. We'll see what that's about. So here we define the delegate that takes the game controller and the event. So every time the state changes, we'll invoke this event. Here we have our level names, serialize field, show up in the inspector, our scene picker. We created that in lesson excuse me, in lesson 5. And a header to separate in the fields in the inspector. So here we have our the layout data in a list, so we can have however many levels we want to load. And here's the controller to control creating and showing the level. Remember from our last lesson, it makes the level from the layout data that it loads, the scriptable object, and then it enables them. We don't want to make the level and enable it on start anymore, so we're gonna create a derived class that overrides the start and just have nothing happen. We're gonna ask the level layout data to load the game levels on demand. So next we move on. We have the level info and an accessor to the level info. Level info is much like the game info here, but it provides more information so we can know what scene we're on and what index we're using from our layout data list. And this is responsible for tracking our game state. Since we're here, I'm gonna go ahead through it. Our game information, again, scene in layout index, default constructor, where we set everything to default values in case we want to create one from an existing one. And this constructor in this method is required by the Serializable interface. So here, if we're creating one from disk or wherever we're serializing the data, deserializing the data from, this is called to set the data. So the info is passed in, we get whatever key we gave it, we convert it, it's always sent back as an object. We have an optional type to let it know what type the returning value should be. It's optional, like I said. There's another method that does it without it. So we set the, oh, I'm sorry, it's optional for the adding. So cool. So we set it here, our game info time, score points, scene name and index, and when we're serializing the data, we add each value to the info coming in. So this is an integer, float, an integer, and this is what I mistakenly said about the getting the value. So adding the value, you don't need to pass in the type. It'll be inferred, I guess, by the compiler. There's so many of them. Okay. So this is for deserialization, for serialization of our type and deserialization of our type. It's custom. We didn't need to set any of these values, or we can have other values that we don't want to set. And you know, I've first time encountering needing this, we're serializing data for a marbles game which use materials, and you cannot serialize the material. So I bumped into creating my own serialized information. That way the material could just be passed as an index or a name or something, and that way you can always have a reference, even a GUID or something more concrete. Okay, so that's our level info that saves our game data. So this is where we were. Layout transform, this is defined to keep the game level when it's created, it's parent, our game state, and our actions. Action for each game state. It's a dictionary. So each game state will define its own action, its own thing to do. Virtual accessor to our game state, so the derived classes can modify. And every time, properties are really handy this way. So every time we set the value using the property, we can trigger on game state change. So this event will be triggered every time without us having to find game state everywhere we set it and trigger the event. So properties can be used that way, and they come in very handy that way. So here's our explicit implementation of the interface for the game state. It calls for public access, and we don't want public access to this. So we define our own, which will be overridden, and anytime the interface is called, it would use this call, which defers the call to our protected. Okay, it's explicit implementation of game state. So here's our iLayout controller, access to our level layout data, the scriptable object controller, and the current layout that's indexed. So whichever of the datas we have selected, we can call our current layout to return that. So in a way, we set our scene. We've seen this before. The base setting our scene name to the level names that we set so we can use the scene pop-up. We create our parent transform for the level we're going to create. We instantiate our game actions. Then we call these two methods. First method adds all the actions for each game state. Second one loads the game data from disk in this case. If this is the first time the data is loaded, the scene name will be null or empty, and we can set default values. Set our game state to start up, and we call our game loop. This is a method from the interface game state to return the exact type of game state that it is. Remember, later down we're gonna create new game controllers that has new and different game states that will be added to this game state list, and from there you can return the exact type of game state it is. We'll see that later on. Here we load our information from disk. So let's stop here and go into our serializable utility class and see how the information is loaded. Okay, here's our static class, serializable utility. It has some methods to save and load the data and some extension methods for the file. So we declare a binary formatter to save and load the data. So we need any serializable interfaces to be able to create a file stream with a predefined name and save the data in a serialized form to that file stream. Right, and to load it, I guess the opposite. Get the file name from the type, call the extension method for strings in this case, which combines our application persistent data path with the whatever string was passed in, and that would give us the name of our file. We set our data to default. Then we proceed in loading the data from disk. So we open the file stream and we go ahead and try to deserialize the data into our object. Well, I recommend, and it's probably recommended by C# documentation also, to use the using around file streams and stuff is they're disposable, so it will use it up and then dispose what it needs to, so you don't have to worry about closing the file and disposing the resources. It'll all be taken care of through this clause. Okay, so we've covered our get name. Now we check this just to see if a data file exists for that type. So we pass in the instance, we get the type, and we call our extension method for the file name, and we return true if it exists, false if not. Deleting the file from disk, there is nothing being passed in. If it's null value, we return. Get the file name, of course. If the file exists, we delete it. So that's serializing the data to disk, and each class is responsible for defining how their data will be saved. So now we add our actions in await for each action. So idle, startup, playing, loading, these are all game states that are defined for this lesson. So we have lesson 5 defined all these game states, and we're going to use them in this lesson to run actions for each game state that the game loop has set. Here's a reset function. So if there's a level layout data controller attached, we see if it has an object that contains the level data, and we would go ahead and add that to the list. Now, when all the pickups are collected, we use the persistent game controller's method. So we will call that, and this is the action we're going to perform. So this lambda will be defined. Let's go ahead and check that out. Take a note of the game loop in the persistent game controller while you're here. So set game state to loading. So this is from the persistent game controller. Disable the input controller, the keys or device accelerometer, whichever we're using, and stop the box controller from moving, and then we invoke whatever game over action is passed in, and then we set the game state return value to loading. I think we're also going to call the playing set to playing in our level controller. These are static, used in our level controller, which does not derive from persistent game controller. So our game loop has been condensed, and all the actions are now stored in this dictionary, which is selected by the current game state, and then we just invoke that action. So this gives us an opportunity in later classes that inherit from this level game controller to add new game states. So here's our idle definition, going through those, our startup definition, our playing definition, to where we just keep adding to the time. We've seen this behavior before. And when we're in loading state, we set the scene name to the currently loaded scene name, We wrap our scene index, which is the level layout index from our level info as the data that we're saving, to its count, to how many are in that list. Then here is where we call our overridden. That's why we overrode this method, so we can call the start and enable ourselves. So when we're ready, which is now that the game is loading, we make the level and we enable it. We set the game state to whatever game state this value returns, which I know is playing, and you should too. So we pass in however many pickups were counted and current time. When game over state has been set, which is set somewhere up here, we save the data file. And this is extension method we created in our serializable utility class. We destroy all the game objects in our parent level layout transform. That's the pickups, the walls, everything. Then we call our base class to load the new level. And we set the game state to loading. And so now we have our level game controller that persists data via this information class that draws the data to our scene view with the level layout data controller, uses the serializable utility class to save it to disk, and it declares an interface that gets the specific game state and forces any subscribers to create a game state variable that we can access. So also for lesson 8, there's an editor script. This is for the level game controller, which we want a little bit more functionality in our editor. So we define a few constants here. This is our usual convention. This is a property name in a class. Declare some properties we want to exclude from being drawn. Declare some properties that we want to draw but be disabled in the editor. We get a build scenes name list. We've defined this class in lesson 5 as the namespace suggests. Define an array for the disabled properties we're going to show, and we create a reorderable list to show our levels that we're going to be loading from the level data. So here, the build scene name, we create one of those. We get all the disabled properties from the serialized object by finding the property on that serialized object with this name. So we have link, system link in here, and gives a lot of shortcuts to get things done. So that's how you would iterate. You would iterate through each of these in the collection and select whatever's in the collection. In this case, it's a string. And we're going to be passing the string in, which is the name of the property, the field in our class, and we're going to find it on a serialized object, which is a normal setting of a serialized property. And when we're done, it returns a collection, and we convert that to an array. So we have all our properties. Convert our target to a level game controller. It's the target type, so we know it's going to be that, so it's an easy cast. Create our reorderable list for our datas, level datas. draw a header for our reorderable list, and draw each element. So in drawing each element is pretty standard. We define the height, define the name of the field, and the tooltip if we want to show one. In this case, if it's empty, we would like to show a specific tooltip. It says that for our element name, we'll show an empty element, then we'll show how we will say in the tooltip how to add a new element. So we have our index. If it's the first index, we're going to disable it. That's the one. If we go into our level game controller in our reset, it's automatically added as the first array element if it exists. So we'll disable it and set it from the controller. But that's just for the first one on the list. Set the tooltip if need be, and we draw our property. Remember, if we're changing the inspector static properties, we gotta set them back, else we'll may have funky behavior later down the line. So now when we add a new, when we click that button, the new add plus button on the reorderable list, we grab that element, we insert a new one, and we set its reference to null, clean element. If we don't do this, it will reuse the element data from the previous element. So now we draw our level game controller in the inspector. Update and push the properties back after we modify them. We draw all the properties from the class we inherit from, excluding the ones that we've named. Again, we're caching the enable, whatever it's set to in the editor. We set it to whatever we want along the way, and we change it back. So we're drawing the disabled properties here. Then we're drawing the list of the level names, the scene names that we're going to be loading, and the data that we're going to be loading for drawing our levels. And that is the entirety of how we draw our level in the inspector. So let's put all that together. So we're starting at new level tests. Press play and say OK. So here we have, what level are we on? I don't even know what level this is. So let's play it anyway. I die. So what I think, it's loading the previous one. So yeah, so our layout index is currently on 2. So this would be the third level in the chain. I don't think I made a way to delete the data. The data is deleted in the next lesson. So what I'm going to do here is give a sneak peek of lesson 9. I'm going to reset all the data that's in there. So now let's go back to our level creator. Okay, we should be all zeros and start anew. Okay, so here we are on the first level. It plays just like any other level. No changes we can pick up. Alright, and in level 9, lesson 9, why I keep lesson level too many of that. Anyway, in lesson 9, our next lesson, we're going to show our game data, the disabled data, in the scene. In the editor, we're going to be showing that in a UI. So Unity has a new UI that we're gonna implement, and that also we're gonna use World UI to display different stuff in the scene. Okay, I'm on a collecting mission, of course. As you see, we're changing throughout the levels that we set up. Here's the data. We can see it's all being maintained. Cool. So you can add scenes with that button. Sometimes it's turned off.